Wine, and my partner's name is Maria, and our project is The Chemistry Behind Wine. So, what gives wine their savory aroma? Volatile phenols contribute characteristic odors to various foods and beverages, including wine. The different compounds are 4-ethylphenol, ethylglycol, and 4-phenylglycol. Each of these compounds have a distinct aroma ranging from sweet to the taste of cloves, and this is what gives wine their good taste. The problem is they have a very low concentration in wine, which means it is very hard to know how much is actually present. In chemistry, this is referred to as the lower limit of quantification. The purpose of this experiment is to develop a process that will allow experimenters to analyze the very small amount of a certain phenol in a particular wine. So, this experiment, they needed to develop a faster method for the quantification of phenols at very low concentrations. This needs to be done so that the experimenters can identify the different phenols that are acceptable for different wines. With such low thresholds, it is essential to understand how much of the phenol concentration is present in a type of wine. So, why did they need a new method of finding these phenols? The old method used high-resolution gas chromatography. And this type of experimentation, the experimenters had to extract a fatty acid before analyzing the phenols, which would take about 4 hours to do just one sample. In chemistry, one sample is not good enough because you need to take multiple samples in order to ensure accuracy. Although high-resolution gas chromatography is the most common technique for the separation of volatile phenols, in this experiment there is a high amount of water in the final product. This water will cause our results to not be accurate due to a loss of the volatile compounds we are trying to analyze. Since this is an error that the experimenter can still correct, the water in the final product is considered a systematic error. In order to avoid systematic error, these scientists decided to try a new technique and use high-pressure liquid chromatography. High-resolution gas chromatography is when scientists convert the sample they are studying into a gas. After they insert their sample into the apparatus and it is converted to a gas, the different parts that make up the sample are separated and recorded as individual peaks. In high-pressure liquid chromatography, the sample is pushed through the apparatus at a very high pressure, which makes the time of analysis much shorter. The sample then interacts with small particles that are on the apparatus. This causes the different components of the sample to come out at different times, which allows the scientist to identify the amount of those different substances present in the sample. For example, in this experiment, the high-pressure liquid chromatography allowed the scientists to see the amount of different phenols that was present in the wine that was being analyzed.
A faster extraction can be obtained by trapping bolaries on polymers by headspace or solid phase absorption. Because phenols are relatively polar and have high boiling points, headspace analysis will not be a good technique. In this case, we will use absorption. Various resins were tested to optimize the method. Resin AG2XA showed the best absorption properties for recovery of phenols. In order to avoid saturation of the resin, both the wine and the synthetic solution were adjusted to pH 9 prior to extraction. After washing the column with water, the volatility were extracted using dilute hydrochloric acid and ether. An attempt to directly extract the phenols with ether failed. This demonstrates that they are absorbing to the resin in two different sites. First, on the nonpolar matrix of the polymer, and secondly, on the possibly charged dimethyl hydroxyethyl ammonium groups. 50 milliliters diethyl ether, acetone of ethyl acetates, gave low recovery. On the other hand, 50 milliliters methanol allow a good recovery, an average of 91%. A dilution of the methanolic extract with the same volume of water was used since it allows a better separation of the four phenols. Elution of these compounds from Ag2XA resin with metal provides an extract containing a significant amount of water, which was difficult to dry for gas chromatography analysis without loss of volatile compounds. This is why we use direct analysis by high-performance liquid chromatography. 25 milliliters methanol allows for good recovery of phenols from wine. Vinoglycol 73.5%, vinophenol 92%, ethylphenol 95.5%, and ethyl glycol 79%. This was an average of 6 repetitions. This table demonstrates that the 4 phenols can be detected at initial concentrations as low as 20 to 40 ppb. As a consequence, this method allows the quantification of volatile phenols arising from fermentations at concentrations lower than those from which they have been proved to contribute to the aroma of wine. The results given in Table 2 show an average coefficient of variation 6%, better than that reported from the quantification of the same compounds by gas chromatography. The two chromatograms show the separation of the 4 phenols in white and red wine. The fact that we didn't notice any interference allowed an easy quantification of phenols at low concentration. The only problem with using this technique was a random precipitation when the pH of some wines was adjusted to 9. This has no consequence on the quantification of phenols, but meant that the samples have to be filtered before extraction.
The problem was that scientists needed to utilize an efficient method in order to accurately quantify the minuscule amount of volatile phenols present in wine. The solution they came up with was that scientists could either use the typical high-resolution gas chromatography or try a different method and use high-pressure liquid chromatography. The results show that in high-pressure liquid chromatography, the percent recovery was much higher and the experimental time was much shorter. Therefore, they were able to conclude that high-pressure liquid chromatography is a more precise and accurate apparatus for quantifying the small amounts of volatile phenols present in wine. And here are our references, and thank you for listening to our project.